Okay, so welcome back to our course in trigonometry. In this video, we are going to start dealing with the 6 trigonometric functions. So the key ideas, things I want you to take away, are the basic concept of what is a function, and then most importantly, what are these trigonometric functions that we're going to be dealing with for the rest of the course. Now, function concept is a big overarching idea in mathematics. I mentioned in the very first video for this course that functions describe the world, and trig functions are useful for helping us describe what I called periodic phenomena, but we'll get to that in more detail later. Let's get to the basics of the function concept. So this is the way I think about a function. What you have are two sets. So you have a set of input values, you got the inputs over here, you got a set of output values, and then you have some kind of rule that gives you instructions as to which input value is matched up with which output value. So if we got a function, each of the elements in this set of inputs should be matched up with exactly one element over here in the set of outputs. These have fancy names. This is called the domain of the function. This is called the range of the function. So a function takes an element in the domain and tells you which element of the range is matched up with that element. Now for the trig functions, the inputs are going to be angles. Okay, the input for a trig function is an angle. And then we have a rule telling us how to come up with a ratio related to that angle. So every angle is going to be matched up with a ratio for each of the 6 trigonometric functions. So we're dealing with these trig functions. They take angles and they give us ratios. Now let me show you how those are constructed. So let me just get rid of this here. And we will take an angle in standard position. Now remember, angle in standard position, we picture the positive x-axis. We are going to take that and rotate it in the counterclockwise direction. So that's my angle theta. So I got an angle in standard position. Now, x comma y, that is any point on the terminal side of my angle. Okay, so x comma y, coordinates of any point on the terminal side of my angle. R is going to represent the distance between that point and the origin. Okay, so these are the 6 trig functions. We have the cosine function. Here's the instructions for finding the value of the cosine function. So remember I told you the input is an angle, the output is a ratio. So the way you find the value of cosine for a given angle is you take the x-coordinate of the point you have chosen on the terminal side, and you put that in the numerator, and in the denominator you put r, which is the distance to the origin. So cosine theta is defined to be x over r. Sine theta is defined to be y over r. Tan theta, y over x. Okay, those are 1, 2, 3 of the 6 trigonometric functions. The remaining trig functions: secant theta, r over x. Cosecant theta, r over y. Cotangent theta, x over y. All right? Now, some of you may have seen trigonometry before in your high school class, and you might say, well, don't we need triangles or something like that? And I was like, well, yeah, but the triangles are kind of here, right? If we think back to when we were finding distances in the xy plane, we put in that little supplementary triangle. Well, there's your x, right? There's your adjacent, there's your hypotenuse. Okay, and we'll relate this back to that right triangle definition in more detail later in the course. Okay, but if we use the angle in standard position as kind of our basic fact, then we got the 6 trigonometric functions defined here in this way. Now notice there is a relationship between these two guys. If you know the cosine, you flip it, you get secant. If you know sine, you flip that ratio, you get cosecant. If you know tangent and you flip that ratio, you get cotangent. Also, look at the pairs here. Notice on each line, one of the functions has the word co in it. Cosine, secant. Sine, there's no co here, cosecant. Okay, notice the pairing there. One of these has the co in it. Tangent, cotangent. Okay, so let's do a quick example here. Find the values of all 6 trig functions if, and let me just go and find the point that I wanted to use here. Find the values of all 6 trig functions if 12 comma negative 5 is on the terminal side of theta. Okay, notice we haven't been told the angle measure of theta. We don't really need that. They gave us all the information we need. We know a point on the terminal side of theta. Okay, so let's think about this. Okay, theta is in standard position. The point 12 comma negative 5 is on the terminal side of theta. Okay, now I know where 12 comma negative 5 is. I start at the origin. Go this way 12 units, then down 5. X was positive, y was negative. Okay, there's 12 comma negative 5. So, that's my angle theta. Remember, if the angle's in standard position, we get to that terminal side by rotating the positive x-axis in the counterclockwise direction. If we ended up down here, we must have gone all that way around. All right, so I got my x-coordinate, I got my y-coordinate. I need to know my distance from the origin. Okay, simple application of the Pythagorean Theorem. That side length is 12, that length is 5. 5 squared plus 12 squared, 169. Square root of that, 13. So my distance from the origin is 13. Okay, so I'll go over here and find the values of my 6 trig functions. Okay, so cosine theta, sine theta, tan theta, secant theta, cosecant theta, cotangent theta. Okay, cosine theta, x over r. Okay, we were given x and y in the description of the problem. We had to compute r ourselves. X is 12, r is 13. 12 over 13. If we know cosine, we automatically know secant. 13 over 12. Sine theta, y over r. Negative 5 over over 13. Cosecant, negative 13 over 5. Tangent, y over x, negative 5 over 12. Cotangent, negative 12 over 5. All right, so we're dealing with these trig functions. The input is an angle. We don't necessarily need to be given the measure of the angle. What we need is a point on the terminal side of our angle. If we're using that point, we can find the distance between our point and the origin. So that's our r. We'll have x, we'll have y, we'll have r. All right, let me do one more example. Very similar, but I want to change up the kind of point that we're given. How about this? Let's find all 6 trig functions. And I'm just going to take the book with me. I'm trying to read from it. It's way over there. Okay, so find all 6 trig functions if this point, let's make it negative 3 comma radical 7, if negative 3 comma radical 7 is on the terminal side of theta. Okay, so once again they have given us a point on the terminal side of our angle theta. They haven't told me the value of theta. Once again, doesn't matter. Let's get a little sketch right here. Negative 3 comma radical 7. Okay, now I don't know what radical 7 is. Don't need to know. Okay, I know I'm somewhere in the second quadrant. Well, how do I know that? Well, x is negative, y is positive. So I would start at the origin, I would go to the left 3 units, and then I would go up radical 7, whatever that is. Okay, so I know that takes me into the second quadrant. So I got this type of situation there. There's my angle theta. That's a sketch of what's going on. Okay, I need to know r. Okay, well, useful little fact here, right? Once again, think of your little supplementary triangle. Okay, there's your x coordinate, there's your y coordinate. Okay, so using the Pythagorean Theorem, r squared equals x squared plus y squared. Okay, so r squared equals negative 3 squared plus radical 7 squared. One kind of fun fact, something to note, whenever you square something, you always get a positive result. If you take a positive number and you square it, you got positive times positive, which is positive. If you take a negative number and you square that negative number, you have negative times negative. The rules for signs tell us a negative times a negative is a positive. So either way, we get a positive result. So that's a positive 9. Radical 7. Okay, now, once again, I said I had no idea what radical 7 was. Okay, I know it's somewhere between 2 and 3, but I don't quite know what it is. And the whole point is I don't need to know. Squaring and square roots undo each other. If I take the square root of something and I square it, it's like I haven't done anything at all. So radical 7 squared is 7. Doot. Okay, think for a second about how I got that. Notice I wrote down a 4, not a 16. Yes, r squared is 16, but notice on the left side I wrote r. Okay, I've already taken the square root. Okay, great. And now we can write down our 6 trig ratios: cosine theta, sine theta, tan theta, cotan theta, cosecant theta, secant theta. When you first start out working with these, I would recommend you write them in the exact same way every time. Cosine, sine, tangent, secant, cosecant, cotangent. Okay, get used to cosine being paired up with secant and the sine being paired up with cosecant. Okay, now we've got all our information here. Cosine, x over r, -3 over 4. Okay, notice any of the trig functions can be negative. The trig functions can be positive, they can be negative. Sine theta, remember, y over r, radical 7 over 4. Okay, notice these guys both have the same denominator, they both have that r in the denominator. Also remember, when you get cosine, you get secant for free. -4 over 3. When you take sine, you get cosecant for free. Flip the sine, you get the cosecant. Tan theta. Notice I don't need r to find the tangent, I just need y and x. Okay, y over x. I could have done tangent and cotangent without figuring out r. Okay, so y over x. Negative radical 7 over 3, -3 over radical 7. Okay, so the 6 trigonometric functions. Okay, I'm going to need you to memorize the definition of those 6 trig functions. Remember what you need. You need a point on the terminal side of your angle in standard position. You need the coordinates of one point, the x-coordinate and the y-coordinate. If you've got both of those, you can figure out r, which is the distance to the origin, and then once you've got that, you can figure out all 6 trig ratios.